All right, there are a few different types of exponent rules that we have to remember in this unit. The first is which, if we have two different things being multiplied together, so for example, 2 to the 4th times 2 to the 10th, notice that the 2 is called the base, and the bases of these, all of these are actually the same. This one has a base of b, base of b, base of b, base of b, and then this one has a base of x. And we're looking at the exponents in particular. So when I'm multiplying out 2 to the 4th times 2 to the 10th, really what we have here, and I'll do this in blue, we have 2 to the 4th, we've got 2 times 2 times 2 times 2. And then in the 2 to the 10th part, we're multiplying all of that by 2 multiplied 10 times. 4, 5, 6, 7, 8, 9, 10. And so what we have, how many 2's do we have? Well, if I go here and I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, there are 14 2's. So I can rewrite this thing as 2 to the power of 14. Now there's a much faster way of doing that. Notice that 4 and 10 are the exponents. When we're multiplying things that have the same base, the powers just add. So I can speed this process up. If I have b to the 4th times b to the 18th, really it is b to the 4 plus 18, and those are both in the power part, so 4 plus 18 ends up being 22, so b to the power of 22. And again, we can do that even with negative numbers, which is really nice. So b to the 4 plus negative 2, well, that's the same as subtraction, right? So 4 minus 2 is 2, so b squared. And it will even work with fractions. I don't have an example of that, but it will work with fractions. And last but not least, I'm doing the general example, so x to the m times x to the n, and that is x to the m plus n. Now, if we do division, it's just the opposite. And hopefully we'll see that. Here we have a power to a power, so 3 squared to the power of 8. And if we break that down, what we have is we have 3 times 3 to the power of 8. Well, we can rewrite that as 3 times 3 as groups of 3. So I've got 3 times 3, that's the first group. This is equal to times the second group, 3 times 3. The third group, and so on. Got 1, 2, 3, 4, 5, 6 times, oh, I'm running out of space, and then times one more. So I have 8 groups of 3. There's my first group, 1, 2, 3, 4, 5, 6, 7, 8 groups of 3's all being multiplied. And how many 3's do I have being multiplied all together? Well, 2, 4, 6, 8, 10, 12, 14, 16. We can rewrite this as 3 to the 16th power. Well, I don't know if you've noticed this, but there's a quick shortcut. 2 times 8 is 16. This even is going to work for fractions, and 5 to the 1/2 to the power of 2 will do us good. So we can rewrite this as 5 to the 1/2 times 2. When we take a power of a power, they multiply. Half times 2 is 1. 5 to the first. If we want to write it in the most simple form, just 5. And again, 5 squared times 1/2, 5 to the first, which is just 5. And here's our general case, 5 to the 1, or 5 to the, x to the power of m to the power of n. We multiply the powers, so this ends up being x to the m times n. When we have powers of products, we're just really, all we're going to do is take our understanding of multiplying numbers together, So 3 times 4, and we have that set twice because we have to the power of 2. Now, multiplication order doesn't matter, so we can rearrange this, and you notice that we have 3 times 3 and 4 times 4, and that can simplify into 3 squared times 4 squared. I think through all of these examples you've noticed that we haven't actually simplified the numbers because we're learning kind of the general idea, and you can just use a quick calculator to compute what 3 squared times 4 squared is. But if you don't know how to do that in the first place, that's where we get into trouble. Again, we have 4 times x, and this will work with variables too. So we've got, I'll change colors here. We've got 4 times x times 4 times x, and that ends up being 4 squared times x squared. Now I've thrown this next problem in here, this 4 times x squared, because this is often confused with this, and this, our 4x squared, doesn't actually simplify. So when I simplify 4x squared, it's different than 4 times x, all of that squared. This cannot be simplified, 4 times x squared, and that's actually our final answer. You've probably noticed a pattern that when we multiply numbers together, like 2 times 9, I can simply distribute that 3. I could distribute that 3. And so that's our shortcut for this. We've got 2 to the third power times 9 to the third power. And that would be the same thing as 18 to the power of 3. It's just we've done the parts differently. And then we have our general case here at the end, a to the n times b to the n. We're almost done. Again, same thing happens with division. We can just when we're dividing inside the parentheses, we can distribute that 2. That 2 can go to both. That 2 can go to both the 3 and the 2. So if we want to rewrite this in simplified terms, it's 3 squared over 2 squared, and in our general case, a to the n over b to the n. So we're just distributing that. And it only works if there's just division. If there's like adding inside, can't do this, only with multiplication. This is where zeros come from. So I'm actually going to add a title, power of 0, because I think it's like an important idea of how we get it. If I have 3 to the 4th over 3 to the 4th, I really have 3 times 3 times 3 times 3 divided by 3 times 3 times 3 times 3. And I see that I have things that are on the top and the bottom. This will become a 1, this is a 1, this is a 1, this is 1, because then a number divided by the same number. So really what we have here is we have a bunch of 1s being multiplied. 1 times 1 times 1 times 1, and that equals 1. Well, if we were to do our subtraction thing here, this is also equal to 3 to the 4 minus 4. Remember how we did multiplication? When I multiplied things with the same bases, they added. Well, when I divide things together that have the same bases, both of these have 3, same base and a power, we can subtract them. 4 minus 4, which is equal to 3 to the 0th power. Oh, hey! Anything to the 0th power is 1. So x to the n divided by x to the n is x to the n minus n, which is equal to x to the 0th power. And anything to the 0th power is always 1. So the x goes away because it's to the power of 0. And this just actually answered this question here. So x to the 0th power is 1.